maximal square, it just focuses us or forces us to say that, bro, you have to go and take a square. That square should have all ones. So if the square has all ones, that square is called as, okay, a square, and the size, as in the number of ones for it, is counted as how many ones are there in the square, or basically what is the area of the square. Now if you go on very basic, again you will see that I have made a bigger example. In this bigger example, you can see that this is the biggest square which you can get. Again, there can be multiple other squares. For example, you can see that this is also one square whose area is 4. This is also one square whose area is 4. This is also one square whose area is 4. This is also one square whose area is 4. So there can be multiple such. Okay, this is also one square whose area is 4. There are many other squares who have area of 1, 1, 1. Now programmatically, we have to find which square has the maximum area. Now if we go on very brute force way, what you will do, you will try for all the possibilities. Now if I pinpoint one possibility, how the possibility can even start off? The possibility will start off by saying, because see, a square has a corner. A square has a corner. Okay, if I know that this is the corner of a square, again, any kind of, let's say, even if it's a square or a rectangle, I can just say that sx sy, which means starting x coordinate, starting y coordinate, and end x and y, ending x coordinate, ending y coordinate, even if it is a square or a rectangle, I can represent them with these just 4, like as in xy coordinates of starting, xy coordinates of the extreme diagonal. I can represent that. Any like square or a rectangle, I can represent that. So if I ask you, okay bro, if I give you a square starting from sx sy, you have to try on for all the possible square, because it is a brute force approach, which is a basic approach in which you will try for all the possible square, and all the possible square for sure. One square can be ending at sx sy itself, or other square can be, okay, ending at here ex ey, or other square can be ending at here ex ey. But Aryan, why you did not count like this portion, or Aryan, why you did not count this entire portion of square? Bro, firstly, this portion was not a square. This is a rectangle. This is a rectangle, not a square. Now on the point of Aryan, why did not count this portion of square? Yeah, we will count it, but I will count it when my starting point will be this point itself. So you will see, okay, Aryan, okay, it means that you are saying that you will try for all the starting points. Yeah, you absolutely got it right. I will try for all the starting points. Now for one starting point, I am saying that I will have these options. Did you realize how many options you had? As in, okay, one option of square was this, only one square. Another option was 2 cross 2. Another option was just directly 3 cross 3. Okay, again, like if I would have asked you what could have been next option, it could have been 4 cross 4. So I could easily see that, okay, for my starting point of sx comma sy, I have n into m points to start off from. Now if I choose any of the starting points, how many squares I can go diagonally, how many squares I can go? For sure, whosoever is minimum, which means x or y. But Aryan, why you choose minimum? Not you. Why you choose minimum? Because what if I had an extra y, but I had no x? Still, my square would have been limited. My square would have been limited because my square want both x and y as equal. So that is the reason I will take minimum. So minimum will represent how many number of such squares I can make. Now, even if I make any square, even if let's say I got 1 point, even if I got 1 point, still my task ultimately was to find the area, as in to find the number of ones in that. So for sure, I will have to go on to all the elements inside this portion. Okay, this ex ey was given me by the diagonal, which is minimum of n comma n. But this area I will have to iterate in on all inside all the cells. Now it at max the cell can be n into m. So you realized that this is the starting point, this is the starting point, this is the ending point, and this is to go on to all the elements to just know, okay, what is the volume, what is the area of that specific square. So you realize, okay, it is n into m whole square, which is n into m whole square, and n, minimum of n or m. So it will be roughly n into m whole square multiplied by n or m, you can say. Can you improvise it? Yeah, for sure we can improvise it. How? Because we have seen, again, if you have not seen or if you have not remember, I'll just do a quick recall of similar kind of improvisation of brute force. If you remember that if I have asked you, bro, can you please find me the subarray sum, then what you used to do, one way is that you can go and try for all the I into like I, if you go and say I and j are the points, are the okay, I and j are the integer values, these two pointers will give how many number of subarrays? N square subarrays. And then when you have got one subarray, you just after that went on and find out, okay, what is the sum of that specific subarray. So this is one way to solve it. Else we have seen, again, this will firstly, n square is the number of subarrays and n is the sum of that specific subarray. Now if I go and ask you that, bro, have you heard the improvisation in which what we do is that we know that while we are going on to j, okay, next j, next j, and so on and so forth. Now while going on to next j itself, next j itself, next j itself, I will keep on adding the sum, which means I will, while my sub arrays are being generated, I will keep on adding their sum, so that again the n square into n, so that this n factor which was coming in because I was generating the entire sum again, that will not be required. I will work by O of n square itself. Now similarly, in this case, I was going on to the diagonals and then I was going on to all the n into m cells to know the sum. What is the sum? But now I will say, okay, while I am going on to all the n into m cells, I will automatically make sure, okay, if that point is the diagonal point or not. So I would not be needing to specifically mention this n into n. So what will happen? My complexity will actually improvise to O of m into n whole square. But still we will see that it is not good. Still we have to improvise it. Now let's come on that how we will improvise it. Again, we are just still revolving around that square and we still have to find the maximum square area. So we realize so far that, okay, we have some point sx comma sy which is denoting the starting point, and we have some point comma like ex comma ey which is denoting the end of that specific square. Now I specifically wanted that I should be able to, again, I was able to solve it in O of m into n whole square time. Now interviewer is asking me, can you solve it in O of m into n time? Now if he is asking me to solve it, and if I go back and look at the complexity which I have achieved, I will see, okay, m into n was to know, okay, for all the sx sy points. So if interviewer is saying me that you have to solve it in O of m into n time, then I know one thing for sure, that he wants me to find this ex ey, or basically to find the maximum area for that specific, let's say if my starting point of the square is sx sy, he wants me to find for this specific point what is the maximum area, and that too he wants me to find in O of 1 time, because ultimately if I have to solve it in O of m into n time, I will have to go on to all the cells. That is obvious. So if I am standing at a point, I will have to find the maximum area in O of 1 time. So now the issue came in that, okay, that how I will find the maximum area in O of 1 time, specifically given that, okay, I will be given 1 point, and with that 1 point itself, I should anyhow will be or should be able to figure out what is the maximum area. So let's take, again, we choose the 1 point as, let's say, starting point. Again, as similarly we can also choose the ending point. Both will work similarly. So let's say I will choose 1 point, ending point. Again, मकसद नहीं बोलना है, our main aim was to find the maximum area, and that too in O of 1 time. So now what I will do, I will simply say, okay, let's now imagine I have only one cell. If I have only one cell, okay, ex ey, and that too, make sure that should be 1. Only then I will count it as a valid square. So if that is 1, I will simply say, bro, I have achieved 1 cross 1 square. Now, okay, bro, that was easy. But you have to find the maximum square area, and that too ending at this point, ex ey. Okay, bro, let's try for a bigger square. Now, after 1 comma 1, next bigger square comes in 2 comma 2. So I will go on to that cell. Okay, 2 comma 2. For that, I have to go and check my above cell, which is, okay, if I am at I comma j, so I have to go and check I minus 1 comma j. I have to go and check the left cell, which is I comma j minus 1. I have to go and check the diagonal cell also, which is I minus 1 comma j minus 1. If all these three are 1, only then I should also be 1, which means I comma j should also be 1. If all these are 1, then only I will say that this is a 2 cross 2 valid square. So what happened? It is still O of 1 operation, because to check at this point I comma j, you just went on up, left, and diagonally up. So that is completely fine. This is O of 3 operation, still a constant operation. Okay, now I also verified that okay, 2 cross 2 square is also valid. But again, main aim was to find the maximum square, so I will still try to go up. If I still try to go up, what will happen? That you will see that I will still have to go up, then the left, then diagonal, then left, then up, then again. So you see, just by having a third try, my searches increase quite a lot. So I saw, okay, as soon as I will do more checks, because here I was very fine. Okay, 1 check, oh awesome, 3 checks, awesome. But this, after seeing this, it seems like I cannot keep on doing 9 checks, then for sure 16 checks. That will go on quadratically, as in exponentially it will keep on going. What I will do, what I should do, then I will see one thing. I will see one thing, that what I will see, I will just see that what was happening. Okay, this is gone. So my entire cool. What was happening? Happening was that okay, you were at I comma j. You still had to do in O of 1 time, as in max O of 3 time. So you are just bound to ask just your neighbors, which is top, left, and diagonal. If you are, and if you have to ask your neighbors, so you will have to ask your neighbors, bro, can you please anyhow let me know that will I be able to make a 9 cross 9, sorry, 3 cross 3 square? So how will they help you? They will help you by saying, bro, I don't know about 3 cross 3 square, but I can, again, this guy will say, bro, I can make a 2 cross 2 square, so I am good. I don't know how it will help you, but yeah, you can take care of yourself. Now, this cell will say, bro, I also can make a 2 cross 2 square. I don't know how it will help you. You can take care of yourself. And this bro will also tell, okay, bro, I also can make a 2 cross 2 cell. This is how I can make. Again, I don't know how you use it. So go do it yourself. So all these told something that they were able to make a 2 cross 2 cell. Now, what happens because of this? If this guy is able to make a 2 cross 2 cell, which means all these cells are actually also 1, right? Again, let's say if this guy is able to make a 2 cross 2 cell, which means all these cells are also 1. Again, if let's say the bottommost guy, if he is also able to make a 2 cross 2 cell, so all these cells are also 1. So ultimately, by my naked eyes, I can see, bro, all these are 1s, which means for sure I am absolutely okay to make a 3 cross 3 cell. But ultimately, how? So this is a diagram, which means that the top of guy, he's saying, bro, I can give you 2. I can give you 2 cross 2. So he gave me 2. Diagonal 1 gave me 2. Left 1 gave me 2. If you imagine this, then imagine this as an empty box of a 3 cross 3 cell. Now you are at here. You know that you have 1. Now the top one, he said that okay, I can give you 2 for sure. Left one said that he can give you 2, and the diagonal one said that he can give you 2. So this is how I can say, okay, I can ask left one, I can ask top one, I can ask my diagonal one, I can ask my left one. Top, left, diagonal, I can ask, and for sure they will give me, and that I will take, and with that I will be able to make my 3 cross 3 cell. And that is how I was able to make it. Now, if we do a summarization, so what will happen, that we will have to do some computation. Now, let's say that I had this problem to find a 3 cross 3. Okay, is it because ultimately I was able to find a 2 cross 2, that was valid, but my bigger task was to find a 3 cross 3. So I asked my neighbors for a smaller sub problem, which was a 2 cross 2 one. And they gave me that, bro, you can do it, because they said that okay, bro, we can give you 2 cross 2 answer, and that we have perfect answer for it, and you can just take that answer. So after taking a smaller sub problem answer from his neighbors, he just attached, or like basically used that sub problem answer to make his own answer of 3 cross 3. So now I'll give you a hint of a pattern of how you can even think of. Again, one word is sub problem, like sub problem. Other thing is that okay, you have to remember this portion, because for sure if he has done this concept, then maybe it can help someone else also down the line. So you will have to remember this, that okay, he has built a 3 cross 3 pattern. So you have to remember that, because he will have to convey that to maybe his child. So you have to memorize that. Okay, we have seen, okay, one is maybe we have some sub problem on which you have to act. We have to also memorize some stuff. This is one of the most common intuition of your dynamic programming. But there's also one common intuition that if something is asking for, again, this is not hard and fast rule, but it is an intuition. If something is asking for, let's say, longest, shortest, largest, smallest, maximum in, there's a high chance that in that TP will be applied. So if you remember, you have to find the largest or maximum area. That is the reason it points us that for sure we can apply DP. Again, all these points are intuition. We still can or cannot prove stuff. Okay, but yeah, that is very obvious about the repeating sub problem, that if we have repeating sub problem, we can just simply memorize that, and thus we can simply apply DP. Now, if we come on, how will we apply DP? Simply, if I take that this is the standard array which I would have had. Again, it is of zeros and ones. 0, I have left it as empty. So if I'm trying to build the array, I will simply be going on to all the elements. Let's say again 0 for 0, everything is 0. Let's say I go on to some random element. Let's say if I am at this location, so you will see I will go on row wise. Okay, this will be built again. I'll just have a quick dry run how I will go. Let's say if I am at this point, I will be at 0. This point again, he has no, I will refer my left, top and my diagonal. So he has nothing on left, nothing on top, nothing on diagonal. So it is 1 only. He is also 0. He is also 0. He is also 0 and he is also 0. Okay, he is also 0. Now for him, this guy, he has top, but he has nothing on left and also nothing on diagonal. So he wants everyone's collaboration. If you remembered, this guy would want everyone's collaboration. What if Aryan, if this would have been a 3x3, if diagonal would have been a 3x3, still I would have to go again. Like when I say 0, I mean actually some things are there, some things are here, some things are here, some things are here. So if still diagonal would have been a 3x3, still I would have to go and say, bro, I can only take a 2x2 because I will have to take what everyone is giving me. I want to make happy left also, right also and diagonal also, because I will take every one of them and thus I will take the minimum of all of them. So as you can see at this point, minimum is 0 itself. So I will just simply take 0 and for sure I had 1. So I'll simply add a 1. And as you can see, simply it will keep on going, keep on going, keep on going. Now, for example, let's say at this point, you will see that, okay, in the DP array which you have built, again, this is your DP array which you have built, you will see left is 1. Right is 1, top is 1, which means left, right, top, you have one thing. So you will take minimum is 1 itself, and then you will add a 1 which is for you. So at this point, what you are seeing, what is happening, that is DP of I comma j, you are just taking the minimum of all the 3 directions because you have to take in contribution of everything, and then adding a 1 considering you have 1. Again, if you don't have 1, you will have to directly stamp a 0 no matter what. As you can see here, or I can even if it would have been a, let's say if it would have been a 0 here, still I would have to put a 0. I will not put a 2 here. I will have to put a 0 here itself. If something is 0, there is no possibility of having a 1 any time whatsoever. So I will have to put I will only be getting onto this condition only and only when my I comma j cell is having a 1 value. So that's how you realize, okay, we can simply solve this problem of maximum square via DP. And also we realize that we just have to take the help of our neighbors, which is left, top and diagonal. Now let's quickly see the code and then we'll go on to the actual problem, because we have to extend that square problem to a rectangle problem. So we will simply have a DP matrix of n cross m. Now I make it of n plus 1 comma m plus 1 just because you remembered I have to go and check for I comma j minus 1, I minus 1 comma j minus 1. I have to go and check for I minus 1 comma j. So I have to go and check for minus 1. If I will start off from I equal to 0, then this minus 1 I have to handle separately by some if condition. That is also completely fine. But I thought, okay, why not just simply have a 1 and by default initialize everything with a 0. That's also completely fine. And then I did simply exact same thing, that if my matrix value is 1, only then come on inside and update your DP value by saying minimum of your top, left, diagonal, and then if you are a 1, because for sure if you are not a 0, so because if you are coming inside, you will be a 1, so you will simply add a 1 for it. And then I will have to update my answer. My answer is the thing which I wanted. So this answer is ultimately, again, if you go back and see that in your DP you are storing a 2. 2 says the square length. But remember, maksad kya tha apna? Our aim was to find the area. So we are maximizing the length of the square. Ultimately, I will have to return the area of the square. So I'll just simply multiply it by itself. You will see that time has reduced to O of n into m, and thus as we are also using space, so space is also O of n into m. Now there's a quick improvisation. I will just quickly walk through it. You will see that, okay, you are using a space of O of n into m because you are using a DP array. But actually internally, as you did also dry run, that for a specific DP array, you only need the top, left and diagonal. So if you only need, if you are computing this, so you only need this value and this value. So why to take all these n rows? You can just simply take 2 rows and get things done. Okay, so that is also fine, that your space from O of n into m will actually only reduce to O of m because we have m cells and we have just 2 rows. So f O of m into 2. Again, if you want, you can also a bit improvisation, you can do it in here also, because when you are making this specific cell, you will be overriding. Again, let's imagine that this is your previous cell, right? This is your, let's say this is your previous cell. So let's say you are overriding this value. So I will say, bro, I will compute this value here. This value I will paste as it is here, which means I will store this. This is the old array. This is the new array. New arrays, this value is computed recently. Old arrays, this value will be overridden with this new value computed. So not to make it bit complex, but what I will try is I will store this old value, previous value, old array, previous value. I will store it somewhere, and then when I would be requiring to actually update this value, and again this is this value itself. So the previous value of this, again I am just trying to show you, if you do it by single array, then the previous index value will represent the new array previous value. The existing value, before updating this, before finding the answer, the existing value of it will tell me the old array jth value. And then as I have stored this in my another variable called as previous, so I will just take that from my previous variable, and thus in one array also I can do. But still, more or less, I have reduced the complexity to O of m space. So again, not to make it more complex for you, I will show you, let's say, 2 rows approach, but still it is very easy. Just remove one array and use one variable instead, and you will still be able to convert this to one row. Now what I did was simply I just modified my DP array by saying I will take a previous DP and a new DP. Now what will happen, that again, if you remembered in this existing code, everywhere wherever I have, let's say, DP of I, here I will replace it with simple DP. Wherever I have DP of I minus 1, I will replace it with previous DP, and wherever I have DP, I will replace it with simple DP. Again, this is previous DP, and again for sure my previous DP needs to be assigned the DP value for the next iteration. So just simply have the assignation, and that is it. So you will see that I will simply have simple exact same what I showed above, and then I will simply assign it. Now you will see a quick thing which is changed, which is you also did a DP of j is equals to 0. Why was this required? This was required because by default in this initial program your value was by default 0, but in this case you are actually using the same value again and again, So if some matrix is not a 1, then it should be a 0. If you will not change it, or if you not put it as a 0, so when you will coming in here, then actually you will be actually picking up a wrong value of DP of j minus 1. That's the reason. If something is a 0, if matrix value is a 0, then please bro simply go on and put it as a 0. Now this complexity, you will see the space have reduced to O of m space. Now the main question was, Aryan, that how I will solve this problem. Now on paper it seems like a similar problem, but as we have learned, we have so strong with the above approach, then we will go and try to do the exact same thing on this. But I would realize, okay Aryan, in that I was asking my neighbor. Okay, this neighbor will say what? this neighbor will say what, this neighbor will say what, I don't know. So ideally, by the above approach, I was getting a maximum square. So by the above approach itself, it seems like if I did to copy, like if I copy paste the exact same approach, I will be getting a maximum square. So okay, Aryan, I think I can use the above approach of DP. I just have to improvise a few things. I will see by code itself how I will improvise it, but I feel like I have a gut feeling that DP can be applied. Yeah, for sure you have, and you should be having, because it seems like a same problem. But let's see. If you go and apply DP, then what will happen? Firstly, you got to realize that okay, copy pasting of code would never work, because that will give you a square area, but you want a rectangle area, and you can obviously see your rectangle area is 6 here. Then you will go on and do apply your mind. You will see, okay, Aryan, earlier I was finding my height, or basically I was finding my sides. Now in this case, I will do one thing. I will use DP itself, but then I will parallelly keep on finding the area also. How? I will do simple one thing. Okay, I will have 1, 1, 1, 1, 1, 1. That was again, I just copy paste the exact same stuff. Then I know that okay, this area is 2, right? So I will just say okay, 1 and then 2. Then again, this area I can see it's 3. Okay, then take the previous value of DP and then add the current value of 1. I'll get a 3. Oh, it seems nice. Again, here it is 1, previous value is 1, I'll get a 2. Okay, because it seems like it is a 2. Then Aryan, what I will do is that okay, here is a 1. Then how to get a 1 here? Because okay, here is a 1. Then I would know that it is a 4, but ideally I have no idea as such how I will get a 4. But it seems like here is a 2, here is a 2. But then I'm getting a 4 here, but 1 also is a here, so I'm a bit confused of how things will go. So, but Aryan, it seems like this 2 indicates. This 2 indicates again, if I make an array here, and I will show my ones by balls, not my balls, by balls. So what I will do, okay, 1 here represents 1 ball, 2 here represents 1 2 ball, 2 here represents 1 2 ball. Now I have to find here what I should put. So I realize that bro, what I'll do, here it is a 2, here it is a 2, and then here it is a 1. So you can obviously see if this says to 0 0, this says to 0 0, and I know I have 1 ball for sure here. So for sure you can see this thing is being repeated. So ideally you might have thought of okay, Aryan, what I will do is now to find the answer here, I will take this area which is 2, I will take this area which is 2, and I will subtract the common area which is 1, and thus I will get a 2 plus 2 minus 1. I will get a 3, and then for sure 1 area is here itself, so I will get a 4 here. Oh, it seems awesome, right? It is working. Okay, let's see. Then let's say we go on to the last cell. Again, we had a 4, then we had a 3 here. Then again, we apply the same formula that okay, I will take a 3 as an area, and then 4 as an area. So 3 plus 4 is 7. So here it will be a number 7, and then I will subtract this common area, which was ideally a 2 minus 7 minus 2, and then for sure a 1 I will add because I was a 1, so I'll add a 1. Okay, what you got? You got a 6, and voila, you got a 6, and that was actually the answer. Bro, DP is working. hold on, that is true, but if you take the exact same example, how will you even build this entire DP array provided you don't have consecutive ones? What I mean by that is, let's try to build a DP array here itself. Okay, 1 1 1 in the first beginning itself. Okay, 1 1 1. Okay, 1 0 1 0 0. You can see exact same thing. I copied. Okay, no worries. Then here by your formula, which you have showed right now, again I'm just showing you that what we have thought of, how to build and verify if things are right or not. Then here it will be 2. It seems nice. Then what will be here? Ideally by the current formula which we have, we can say okay, Rn is 0, and you also mentioned 0 will be 0 itself, so I will skip it. Okay bro, you can completely skip it. Then here you will say it will be a 2 ideally, but ideally you have put a 1. Why you have put a 1? Because you were checking for the back value. But Aryan, you said now that I will check this value, this value, and this value, and by that fact I will just do a 1 minus 0 plus, like 1 plus 0 minus 0, it will be 1 plus 1, that will be 2. Okay, ideally that makes sense, it can be a 2. Then you come on to the specific value which is 1. You will again go and check, okay, 2 minus 0 plus 2 minus 0, sorry, 2 plus 0 minus 1. Give you a 1. Okay, add a 1. Okay, you got a 2. Seems nice. Then you got a 2 here. You went again. This is a 2 minus 0, and you will get a 3. Things are going nice. Okay. Then you came on here. It will be a simple 3. Now, you came on here itself. Now starts the issue. Again, everything here seems nice. It was going valid by your formula. But here, things start being a bit issuing. How? You have a 3 here, right? Then you have a 0 here. So 3 plus 0 will give you a 3. Minus 1 will give you a 2. Plus 1 will give you a 3. So ideally, here, will you put a 3 here? I can simply see my rectangle area is maybe this, or maybe it can be this, but it will go by this ends. So by so far, area seems like 2 only. And if this value is 3, again, if I put a 3 minus 3, like 3 plus 0, minus 1 will be a 2, plus 1 will be a 3. So I am getting a value of 3 by the formula which I have made, which is kind of working here, but not working here. Ideally, this should have been a 2. This value should have been a 2. But I could not get a 2. I got a 3. So there's a flaw. What was the flaw? Maybe I'm just, here it is a 3, which is this specific value. This value itself I was subtracting. So I should ideally I should subtract this value, which is 2. Okay, you can make sure that you can subtract this. So you will end up doing is that 3 plus 0 minus 2, which is 1. And then you can simply add a 1. Okay, you got a 2 here. Oh, you got a 2 here. But then you got a 3 here. You got a 2 here. Okay, but then if I have a 2 here also, then if I come on and ask for this value, 2 plus 2 is 4 plus 1. 2 plus 2 is 4 minus 0. Okay, 0 plus 1 is 5. How the hell? What is making 5 here? What is making 5 here? Nothing. Because this 2 represents this thing. This 2 represents this thing. And this is one cell. Ideally, it should be 3. But I got it as a 5. So I realized that even if I'm putting values, but any point, I'm coming to a point where it is expecting that other portion is also ones, which I'm missing. So by this formula, things are not working out. And we can try for multiple stuffs, but in a point, we're actually missing stuff. This again, if I try to work on this point, then maybe this will fail. If I try to work on this point, then maybe this will fail. So if I try to work for one point, other point is failing. Then I realize, okay, it is super confusing to work with it, and we realize it is not working perfectly. The DP value, the DP approach which we are taking, and that too, which we are borrowing from the Maximal Square. What to do now? Whenever you have confusion, break the problem down. Whenever you have confusion, break the problem down. So I got my existing problem. Okay. Now my main task was to find the maximum area of a rectangle. Now it was a matrix, so it was a bit difficult. What if I just break it down and I just imagine, okay, rather than a matrix, I have just one row. I have only one row. Maybe how I am just breaking down, I'm just saying, okay, maybe I have one row, and let's say you can also imagine maybe I have just one column itself. But if I have only one row, I will expand that row. So I am starting from a smaller problem, and then maybe I can go into a bigger problem. So I just thought of, okay, maybe I have only one row. If I have only one row, then I can simply apply a consecutive ones. If I have an array of only ones, so array of consecutive ones will give me the largest rectangle. That will be my answer. Okay, so in an array of one, in a row of one, you can apply that funda of array of consecutive ones. That is simple. Sliding window or a 2-pointer will work. But now you have to expand the rows, which means, okay, right now you took one row. What if you have to take 2 rows? Okay, let's say if I take 2 rows, then what? Which means I'm taking these 2 rows. So are you saying, Aryan, okay, if I take these 2 rows, which means I will again apply the same 2-pointer or same sliding window funda of accumulating those values. So ideally, by your fact, if I club these 2 rows and make a single row so as to apply the above formula, then I will club it and make it like this. And then I will take the consecutive elements sum, which will give me the maximum sum. That is what you are saying, Aryan. By your ideology, I will take these 3 elements, and that is giving me maximum answer also. Seems nice, but it is wrong. How? A simple example can actually get things done for you. How? Let's imagine I had asked you this formula, like this example. By this existing thing, you would have taken a 2 2 and would have given the maximum answer. You would have said this is the maximum rectangle, but ideally it is not. Ideally maximum rectangle area is 5. So maximum rectangle area is when I took all these 5 elements and not these 4 elements. Oh, so this 2-pointer or sliding window approach will not work here. You see that how we are thinking of approach, and then we are invalidating that approach. Now, I realized that it will not work. Then I came back again, and then I looked at the problem statement again. Okay, I realized that I cannot club the numbers, because after clubbing the numbers, I got these numbers. And after clubbing the numbers, I got these numbers, and I could not apply any operation. When the numbers are distinct or separated out, then I was able to see, okay, things are working like this. Things are working like this fashion. So I thought of, okay, let's distribute the numbers out. Now, if I distribute the numbers, I can just imagine every number as a block also. So that problem of distributing the numbers in a line and then representing them as a block will give you kind of a block diagram in which this is x-axis, and at every point I have some blocks. That blocks represent the height. So maybe I can represent this as an entire bar. This is a bar, this is a bar, and so on and so forth. So, we transform our existing problem to a sub problem, saying now in this specific diagram, I have to find the maximum area of rectangle. Okay, is it matching any problem? Yeah, it is. So if we go on and see this, okay, I have not written here. So this is actually the exact same problem, which is problem number 84, largest rectangle in a histogram. So we realized that we have reached to a point that we are solving a problem of maximum rectangle in a histogram. Now, again, a question, how to solve it? Again, a question of how to solve it. I have to find the maximum rectangle area, and for sure, whenever you have doubt, just go on and take a sub problem again. So I have to find the maximum area of this specific histogram. Now, what will contribute to an area? Maybe one row, maybe another row, maybe another row, and so on and so forth. That will contribute. So let's imagine right now, let's say this row is contributing, or let's say, no worries, let's say this row is contributing. So if this row is contributing, if I'm just imagining, what if I'm asking you, bro, what is the contribution of this row? Then you will say, Aryan, I can see the contribution of this row again. The fact that you want to take this row, the fact you are just loving this row, or like loving this specific point or column, if he will contribute something, then he will say, okay, he can contribute this area entirely, this area, this area, this area, and also like this area. Okay, seems nice that he can contribute this area. Then what was but yeah, then I can also ask the same thing for the other points. Okay, what, bro, if I go and ask you what you will contribute, so he will say, bro, I am 6, but I cannot see anyone which can even come with me to contribute. But Aryan, he can see a 5, he can come in, right? That's an issue. So you have chosen a 6 and you are asking him to contribute. So he would want to form a rectangle. Now, to form a rectangle, you should be having like this, which means if you want to expand, you should be having the same height. As you saw in this, when I was at 2, I expanded at the same height itself. I could not expand much further because of the limitation of 1, and not much further on the right because of the limitation of the array itself. But I expanded. So for expansion, I need someone to be at least more than me or equal to me. Only then I can expand. But Aryan, with this fact, what you are saying of expansion and going on to all the points, because I have chosen a small problem and I am going on to one point at a time. So with this fact, what is happening is that, okay, to find the answer for this point, I will go in the entire n direction. Okay, same way to find the answer for this point, I will again have to go in the entire n direction. So by your example, you are saying to find the answer for one histogram, it will take O of n square time. I'll say, bro, you are right, but if you will take O of n square time in just finding the answer for one row, and you imagine that here I took just one of the patterns, again I will have to expand that. So it is obviously I can see things are going much beyond O of n into m time. So now the interviewer asks you, bro, can you improvise this? Again, you have n points on the line. Can you improvise it rather than going to O of n square time to find the maximum area of histogram? Can you do it in O of n time? Now, again, the question comes in, if I have to do it in O of n time, which means for every point, I should be able to figure out this entire width in O of 1 time. And what is the bottleneck? Why I cannot figure out in O of 1 time? Again, let's take the exact same example of this specific 2. So for this specific 2, I have to find the entire width of this in O of 1 time. What is stopping you to find the width in O of 1 time? Aryan, the thing is stopping me is I never know where I have to stop. Are you serious? You know exactly where you have to stop, because if you are at 2, you will stop at a point which is less than 2. If you are at 2, you will stop at a point which is less than 2, or maybe it ends. Oh, so I realize that Aryan is saying that if I am at a point, let's say I will have to look for a smallest, again, the nearest smaller element than me. If I am at the ith index, I have to look for a nearest smaller element to the left of me and nearest smaller element to the right of me. That is what I have to find. Have you heard this statement before? If not, then right now let's hear this statement. So whenever we have to find, okay, where is this gone? मेरे notes चलेगा कहीं पे, but cool. Yeah, so whenever I have to find the nearest to the left or right, which is smallest or largest, okay, nearest to the right, which is smaller than me, nearest to the left, which is smaller than me, nearest to the right, which is larger than me, nearest to the left, which is larger than me, I can choose to do one specific pattern. What is that called? That is called as a monotonic stack. Again, anytime, whenever in your future, in English words, you hear or you interpret that I have to go and find nearest, smaller or larger, please go and apply monotonic stack. Monotonic simply says it is either increasing or decreasing. Stack is a simple stack. Now, what I mean by that is I will again go and show you by going on to all the points, and I will then a dry run to show you how that will help you to get the answer. So you are at this point. Firstly, if you remembered that when you were at this point, Aryan, by your statement of monotonic stack use case, you said nearest to the left, nearest to the right. But here in this case, you are going in both the directions. Yeah, okay. We will go one time, we can go left, one time we can go right. So we will go in both the directions, both left also and right also. So what I will do again, I will just try to follow this wordings of monotonic stack. Again, I just know right now that Aryan have told that whenever I have to go and find the nearest smaller or larger element, I use a concept called as monotonic stack. I'll just simply apply that. I don't know how this works. I don't know how he will implement it, but let's say I will apply that in dry run. So I will be here. Again, I'll go on to all the points. That is my first use case. At this point, I will check for the left. Okay, left, but things should follow that. Things should have his height. Right, I will try to go, but right itself is actually 1, which is smaller. Okay, so okay, by this fact, I will not be able to go anywhere like left or right. Okay, if I am here, then I can go left very easily because my left one is bigger, so I can go left. Okay, then things I can simply see that I can go in the length of 2, right? Or I can easily also say that okay, if I am at the index 1, this is the index 0. So I will try to keep on going, and ultimately maybe I can just land onto this here. As in this example, he will try to keep on going, but he will ultimately land in here and he will say, okay, this is the thing which I will never go to. So again, you can just interpret it any way, but I'm just showing you that, okay, if he's at right, like he's at this point, he will try to go right. Okay, right, he can go. So he can go right. So if I go and ask you, what is the answer if you were at this point, at this index, what is the answer? You will simply say, okay, the height was a 1, the width, the left width was a 2, the right width was a 4. Ultimately, the entire width is a 5. Right, and you will say height into width is your area of rectangle. So the contribution of a area you will get by this fashion. Okay, and the same way, let's say I will keep on replicating. Okay, here I am, I will try to go left. I cannot go because just beside me he is 1. If I am here, I'll go right. I can go because beside me, like right side of me, I have 6, which is large, so I can go right. Okay, awesome. Then again, if I am here, I will try to go left. I cannot go left. I'll try to go right. I cannot go right. Okay, if I am here, I'll try to go left. I can go left, but I can not go beyond it. If I am here, I'll try to go right. Okay, right, I can go. Let's say again, I am here, I cannot go left, I cannot go even right. So this is, you saw, I went on to all the points, and for every point, I am trying to see what is the farthest distance he can go in the left. Why Aryan? Why only left and why farthest? Because I wanted to have a maximum area of rectangle. So I realized that I will be able to get my left width in O of 1 time, right width in O of 1 time, and height is for sure constant at the ith index. Height is height of I. Okay, now things are sorted, things are simple, fine. I will be very easily able to get the answer. Just one thing, Aryan, just one thing. That can you please help me out? How are you actually finding this, and how I will find. Okay, this I will know. I have to apply monotonic stack, but how I will know it is increasing, decreasing, or I'm always confused in this. But I never know it is increasing, decreasing, and I'm just confused every time. So what you will end up doing is, okay, you will have to go again. One thing you know that this is what a monotonic stack will do. Now you were, let's say, at this index I. You will try to go on to all the points until you reach one point. So, and what is that one point? That is anything which is just smaller than me. Anything which is just smaller than me. So what are you actually doing? You were, let's say, at I. You are going up till that point, which is just smaller than you. And at that point, you have to get in O of 1 time. Now you know, okay, you are using a stack. Again, I'm just trying to make sure that you understand this pattern, and then you just link it with some ideology which I'm telling you right now, and then you can just easily be able to code it up. Because many people are actually confused. Even if they get to know if it's a monotonic stack, still they are confused that, okay, how will I refer my stack? How will operations will go in my stack? What to remove and what not to remove? So to solve this issue, I'm telling you a trick. What is the trick? You realize that, okay, you are at the ith index. So right now you are having a value of 2. Okay, at index 4, right? Make sure all the words. At index 4 you have a value of 2. Then you realize that this is what you wanted, which is the nearest smaller to the left, and that too you wanted in O of 1 time. You are using a stack. What is one thing which stack can give you in O of 1 time? It will give you the top of the stack in O of 1 time. So I realize that at the top of my stack, I should be having the index of 1. Again, I will store the indexes, and by the indexes, I can easily get the values. Value is 1 itself also. So I will store the indexes. Now, if I am at the ith index and I am saying the top of the stack is 1, so that I will be able to find the leftmost in O of 1 time, I am actually inferring that 5 and 6 were removed from the stack. 5 and 6 were removed from the stack. So then, I will be able to realize that 5 and 6, imagine 5 and 6 would have been there, but ideally, again, 5 and 6, I have put in the values for now, but ideally in the code, we'll put in the indexes. So 5 and 6 would have been there, but ideally because of 2, I would have removed this 5 and 6. So I got to know one thing, that if I am at a value, let's say my value is heights of I. Heights of I is my value because I am at the ith index. And let's say the top index ID is, let's say, st dot top. Because remember, I will put in the indexes here. So imagine the ID at the top index is st dot top. So this value itself will be my height of ID. Height of ID is the top value which I will be having. Now, ideally, by your use case, I'm saying if my height of ID is less than or equal to my height of ID, then I should pop this element. I should pop this element. If not, then I will see that who is here. Here is 1. Here is 1. And thus 1 will tell me, bro, I am smaller than you, bro. So if he is smaller than me, then I will have to stop here. So you realize that how will you write the code? You will write the code by simply saying, where is my code? Yeah. So you'll simply say, okay, while your heights of I is less than or equal to your heights of ID. Again, ID is the top of the stack. And then you will simply keep popping the stack top. And for sure, as you pop, you will update the ID because ID will be the now new top. And then when you are done popping stuff, then for sure you will have to push I also. So you will just simply push your I. And what will happen with this? Your left of I, which means if I go back up, your I, this I is the index, fourths, like 4, left, it will become a 1. Left of I will actually become a 1. Right? So what I did here is that for this point 2, for this left of 4, it became a 1. Same way, left of 4, sorry, right of 4, what it should become? Tell me, 10. It should become, again, you will see that I want the nearest smaller. I will keep on trying, but I will land onto index 6 because everything is out of bound. Everything is out of bound, so it will be 6. So if I know that right is at index 6, right is at index 6, which is at this location, left is at index this, what is the width? What is the width? If it is 6, it is 1. What is the width? Width is right minus left is 5, but I see my width is 4, so I'll do a width is right of I minus left of I minus 1. It is actually the width for me. So height I know, width I will get to know by this fashion, and I am sorted. Now coming on back, I was able to find the width by saying right minus left minus 1. And how I did use my stack? I simply, as I showed you, I was looking for something, and that too, if I'm looking for something, I want to bring it in over one time. So everything which is apart from him, I will remove it, and thus I will, in that fashion, I will try to write my code that things other than him, I will remove them. Again, anyway you can implement it. You can also store in this value in your indexes. Again, there can be multiple ways to implement it. How easy you want to implement it, that is up to you. You can, for this left of I, you can also store your 2. You can also store your 1. If you store your 2, then you will have to change a bit implementation of finding the width, right? So I'll do the exact same stuff, that I will initialize my ID, but make sure that, okay, by default, for let's say any one, left will be -1, and by default right will be a n indexes. So by default, I will say that my stack will have a by default value of -1. So I'll do a stack dot push in the very beginning as same -1, and then I will just take the top of the stack, and then I will keep on following this entire method, and then I'll update my left of I. I'll help you in dry run also, and the same way, exact same way I will do it for my right. But the only case is that I will move in from the right rather than from the left. For left, I am moving from the left itself, but for right, I will move from the right itself. So exact same case, exact same use case. The only thing is that here my I is moving from the right, which means I is moving from n-1 to n equal to 0. Here my I was moving from 0 to n-1. This is the only difference, and that everything else is exactly same. I am updating my right. When my right and left are updated, I am very good to find my answer, which is the width, maximum width at that specific index I. And height I for sure know. Now coming on to a bit dry run for the folks who want the dry run. Dry run will look something like this. So again, I will populate this left value, and left value will be the index, and I will show you the stack also, how the stack will look like. Cool. In the very beginning, I will have to push in the stack of -1. Now I will be at the index 0. Value is 2. I will go and find. Firstly, I will have to go and find by your formula, Aryan. You were going and find and were doing. You will do a stat.top, and then you will actually be doing the heights of ID. But heights of negative index, which is -1, can result in a runtime error. So you have to have a quick check. If your ID is not -1, only and only then go to your ID. Only and only then address your ID. And same way for your right indexes, if your ID is not equal to n, then only and only n, like address, or basically check for the index of that specific ID. Now, in this case, I will have nothing whatsoever. So I will have to put in, I will just say, okay, his left is -1, and then I'll put in indexing of 0. Then I will be at my index 1. He will say, bro, my value is 1. What is the stack top? Stack top is the index 0. His value is 2. Okay, his value is 2. Then what should happen ideally? Sorry, there was noise. I was just scared what happened. So what ended up happening is that, okay, his value is 2. I am a value of 1. And by our ideology, if I am less than whatsoever the top of the stack, I should remove it. I should remove it. What we did, I will simply remove it. Then I will get an index of -1. Oh, I cannot remove it. So for him also, leftmost is -1. Okay, great. Then he will be at this location, 5. Sorry, he will be at 5. Now, if things are at 5, again, you will go and have it again. Sorry, when you're done with the index 1, we'll push the index 1 also. When you are at index 5. Index 5, you'll go and check your top. Top is less. Only if the top would have been more, I removed it, but things are less. So firstly, if things are less, I will mark. First, I have to mark that, bro, for me, left is you only, which is the top one, and then I will push in myself also, index 2. Then I will go at 6. For him, the top one is less. So for 6 value, 5 is less. So for index 3, index 2 is at the left. So he'll at 2. And then he will push himself also. Sorry, index himself also. Then I will go on to the index 4. Value is 2. 2 is less than 6. Remove 6. 2 is less than 5. Remove 5. 2 is less than 1. Oh, so left for 2 is 1. Okay. For index 4, left of him is index 1. And then put in the indexes of 4. Okay. Now 3. Left of him is 2. Left of him is 2. Less. He is more. So if he's more, he will be put in. Okay. I'll put in him. Then index is ended. So if I put in him, firstly, I will have to also update. Okay, it is 4. And that is how you updated your left. And the same way you will update your right also. Same way you can update your right. Exactly same. The only case is that instead of -1, you will have a n, which is 6. Which is 6 for the example case. Now, the code is exactly very simple. To make it very simple, I have, again, there's also a case again. The space, time, everything will remain exactly same. Just to showcase and make it simple for you, I have used the array left and right. That is not required. That will not be required. You will see very easily. But stack will for sure be needed because it is monotonic stack. Then you will have a vector left and right. Then you will simply push your -1. Okay, you have pushed that. For the left, you will push it. Then you will go on from the left direction, get the ID, check if it is not -1. Check if the current element is less than whatsoever I had top. Keep on removing it and then push the current element and then mark the left also. Same way, do the exact same stuff. Again, make sure to empty the stack. Make sure to push the n in the stack and then repeat the same process from the end. Now, from the end, I'm performing the exact same operation. Now, I have gotten the right also. So this gave me left, this gave me right. I can simply, I have right, I have left. I can simply go and find the width. This is the width. This is the height. Height into width is the area. I can now maximize my area. And that is how I can simply get my area of the histogram. So by this, you will see my time is open, space is open, and that's how I can simply get my area. Now, coming on that, Aryan, you have got in O of n time everything, which means now you are good to come back to the original problem, which is maximum rectangle. If I come back to that maximum rectangle, What was I doing? If you remembered, we stopped. Okay, we were taking this specific array. We took one array and we thought of, okay, it is simply a continuous sub-array problem. But then we expanded that and then we realized, we cannot solve it. Then for that, we learned this histogram problem in which we find the maximum rectangle area in a histogram. But ideally, Aryan, this is one such example. And then again, for this specific histogram, you can find the answer in O of m time, you are saying. For the next histogram also O of m time. But can you see? You will have O of n square histograms. Oh, for every histogram, because you can see now, okay, 1, 2, 3, right? And the same way, let's say if I start from the row 2, okay, 1, 2, 3. So you can easily see I will end up having O of n square histograms, and for every histogram, I will have O of m time. So complexity wise, it feels like it will be O of m into O of n square into m. Now interview will ask you, can you improvise it? Can you improvise it? So you will say, yeah, we can improvise it, but what is the bottleneck and how much? For sure, if it's a matrix, we cannot reduce below m into n. So I currently right now I am at m into n into n. I have to improvise by just saying that I will not go on to all of these n square pairs. I'll go just to n values. How that is possible? That is possible by just saying that, bro, right now you were at, like, you are trying, what you are trying is, you are trying, okay, this, then this, then this, and then this, and so on and so forth. I am saying, bro, why are you even trying this? Now you will say, I don't know, for sure I'll try all the possibilities. I'll say, no, bro. Let's say if you take this as a specific portion, what you are finding from it, you are finding the maximum histogram, maximum rectangle in this histogram, maximum area of rectangle in this histogram. If I ask you, why did you even miss it? Like, you could have taken this also, but because you have to find maximum, so even if I have this or I have this, it will never matter. It will never matter. As in, like, answer will increase only, right? It will never decrease. So, but then you will say, Aryan, then why not you take this? Bro, base remain like this. I'm just trying to show you the length of the histogram. Oh, this is the length of the histogram. So for length of the histogram also, you are trying for different lengths, which means if, let's say, I fix this length right here, which means this is the base point of the histogram, then once you are trying, once you are trying this only length, once you are trying this length, once you are trying this length, once you're trying this length, bro, you have to find maximum area. So why not in the very beginning itself try for the maximum length, which is I will try for the maximum length at every point. This bring my solution to a point that, okay, what I will do is I will try, okay, this as the base point and this is my maximum length. Okay, now this is the base point, then this, sorry, if I remove it, this is my maximum length. Okay, if this is the base point, then this is my maximum length. Again, when I say maximum length, I mean I will build a histogram from top of it. So if I replicate that, let's replicate it. So if this is the base point, right, I will build a histogram, and when building a histogram, I'll simply say, okay, 0, 1, 0, 1 and 0, 0. As you can see, again, I want a simple heights array. If you go back and look for the existing code, in this, again, I use exact same snippet function, exact same one. I use exact same function. In this, it requires a heights array, which is a simple 1D array. So, and ideally, I also realize that I will simply copy paste this. I'll get a 0, 1, 0, 0, 0, 1, 0, 0. Then at the next base, I am at the now next base. At the next base, I again want the entire histogram height, which means I want to say, okay, okay, whatever it is 0, it is 2, it is 0, it is what? Bro, this is gone. Base cannot cut, and then this is not a cloud. You should be continuous. It is also a 0. It is a 1. It is a 0. So then you see, I have to update a 0, then it will be a 2, then it will be a 0, then a 0, and then a 1, and then a 0. Got it. Then next base comes as this. Again, if I show you, this will be a 0, a 3, again a 0, 1, because of this specific one now, a 0 and a 1. So he will become a 0, then he will be a 3, then he's a 0, then he will become a 1 because of this specific 1, then he will again become a 0, and then he will again become a 1. Again, next base. Again, you see what is happening? We are doing a prefix sum. We are doing a prefix sum. So there's a new concept now we learned, which is a prefix sum concept. That it simply say, okay, take the previous value and simply add it to the next value. So I'll just simply do a prefix sum. Again, it will become a 1 now, it will become a 4 now, it will become a 0 now, it will become a 2 now because of this 1 and 1, and this will become a 1 now. This will become a, this will become a 2 now. Okay, now last base is this. Again, this will become a 2 now. Again, I'm just taking this value, adding it with the existing value. It will become a 5, it will remain 0, it will become a 3, it will become a 2, it will become a 3. And that is how at every step I will generate this heights array, pass to my function, ask him for the maximum area of the histogram, and then I can simply update my answer. The code is pretty simple. Firstly, you will see I copy pasted the exact same piece of snippet. My actual function starts from here, which internally calls the exact same function which we saw above. In this, we'll simply go and firstly make the heights array, because I have to get the heights array at every point. In the very beginning, my initial row, which is the row 0, whatsoever value it has, I will copy paste the exact same in the heights array. I cannot directly allot it because this is a character matrix and this is the integer matrix. So I will have to convert things up, or maybe add a if condition. Now, when these things are done, I will go on to all the rows. At every row, I will have to compute the new height array. So apart from the first row, because for first row I have already got the height array, apart from the first row, I will go on to all the other rows. Again, if the matrix value is 0, make it as a 0 no matter what. If not, then existing heights value, add the corresponding new matrix value in that, and thus you will simply keep on accumulating or doing a prefix sum, or basically doing a accumulation sum of the heights value, and thus you will get the answer of heights for this specific row of I. Then you will check the answer for the ith row. What is the maximum area? You will maximize your answer for all the rows and thus get the answer. Thus you are going on to all the rows n. For every row n, you are finding the maximum area in the histogram by applying a O of m, time complexity. So time is O of m into n. Again, this m is to iterate on. Again, for this specific row, you firstly go on to all the rows to find the height array. When you have got the height array, then you iterate on, then you actually pass on to a function to find the maximum area of the histogram. Thus, you will simply have another m here to find the maximum area of the histogram. And thus my total time complexity is O of m into n. And space for sure, stack left right, you can just say space use will be O of m itself. And that's how you can solve it. In this video, you learned about DP, what all are the intuitions of DP, which means you can have a repeating subproblem, you can have increasing, decreasing, maximum, minimum, max, min, these kind of things. You then learn when you will use monotonic stack, what is the intuition for it. If you're confused on how to write the code, how will you even figure out what code should be written for that monotonic stack, if it is increasing, decreasing, or what? Because stack will be either increasing or decreasing, but what it will be will depend upon these tricks which we got to learn in this video. Then we learn about few basic things, which is prefix sum and all that stuff. And we learned 3 most important interview questions in this video. Cool, bye bye, take care. I know the video has been a bit big, but if you liked it, please smash it, like baby. It'd be very helpful. My mic stopped working and I'm just pissed off right now because this is not even switching off, not even turning off. I don't know what's happening, but yeah, cool. Bye, take care. Bye bye.